Dear viewers, in today's presentation, we will delve into the implementation of the NOT logic function using a 4-to-1 multiplexer. Our primary aim is to demonstrate the application of logical gates and their corresponding operations through the utilization of a 4-to-1 multiplexer. Below, you'll find a block diagram of the multiplexer for your reference. This multiplexer is equipped with two select lines, S1 and S0, along with four input lines designated as I0, I1, I2, and I3. Additionally, there is a single output line labeled as Y. Furthermore, the multiplexer includes an active high enable input, which serves to enable or disable its operation as needed. We would now realize the NOT function using the 4-to-1 multiplexer. Now, let's examine the truth table for the NOT logic gate, accompanied by its symbol for your convenience, as depicted below. This logic gate features just a single input, designated as A, and a solitary output, labeled as Y. Given its single input nature, there exist two potential input combinations, logic 0 and logic 1. As the logic gate functions as an inverter, the output is the complement of the input logic value. Prior to implementing the NOT gate using a 4-to-1 multiplexer, it's essential to provide a comprehensive explanation of the block diagram. Within this diagram, we observe two select lines, S1 and S0. Additionally, we have designated the enable input as active high, necessitating its connection to a logic high level, typically represented as positive 5 volts DC. Now, let's revisit the truth table of the NOT gate once more for clarity. For a NOT gate, we are dealing with just a single input. Therefore, we can simplify the connection by joining both select lines, as illustrated in the diagram, and label this joint connection as input A. In this circuit configuration, only input I0 and input I3 will be active, while inputs I1 and I2 will remain unselected and unused. Now, we can proceed with our attempt to implement the NOT logic using the multiplexer. We'll begin by focusing on the select lines, which are combined to create the NOT input and designated as A. In this setup, we connect A to logic 0. Consequently, the input line I0 is now chosen to determine the output. To adhere to the truth table of the NOT gate, which necessitates a logic high output for a logic low input, we establish a connection from the input line I0 to a logic high. This logic high signal is then routed from input I0 to the output Y, as illustrated in the figure below for your reference. Now, let's introduce a logic high signal to the select line, which serves as the input for our NOT gate. In this configuration, we connect A to logic 1, effectively providing a logic high to both select lines, S1 and S0. This, in turn, causes the input line I3 to be chosen at the output. In accordance with the truth table of the NOT gate, which requires a logic low output for a logic high input, we establish a connection from input line I3 to a logic low level. This logic low signal is then directed from input I3 to the output Y, as depicted in the figure below for your reference. It's important to note that the input lines I1 and I2 remain unselected in this setup and can either be left unconnected or disconnected. To implement the NOT logic using a multiplexer, we can employ the 74153 IC, which is available in various technologies like CMOS or TTL within the IC family. Below, you'll find an illustration of the physical layout of this IC. The 74153 is a dual 4-to-1 multiplexer, featuring common select lines and active low enable lines. This means it houses two 4-to-1 multiplexers within a single integrated circuit. On the left side of the IC, there's a noticeable notch, and just beneath it is the first pin, designated as pin 1. The pin numbering proceeds in an anticlockwise direction as illustrated in the figure provided for your. In this section, we will explore the internal diagram of the IC 74153 and gain an understanding of its pins and their functions. To enable the IC's operation, we first need to provide the supply voltage. Pin 16 is connected to a plus 5 volts DC source, while pin 8 is connected to the ground terminal of the power supply. The active low enable inputs are denoted as the strobe input G1 at pin 1 and strobe G2 at pin 15. It's important to note that both select lines are common to both the upper and lower 4-to-1 multiplexers. The inputs for the upper multiplexer are connected from pin 6 through pin 3, while for the lower multiplexer, they extend from pin 10 to pin 13. Now, let's examine the functional table of the IC 74153. When either G1 or G2 is connected to logic 1, regardless of the input states, the outputs will be set to logic 0, effectively disabling both multiplexers. To activate both multiplexers simultaneously, you need to connect G1 and G2, i.e., pin 1 and pin 15, to logic low. When the select lines are set to logic low, i.e., B equals A equals 0, both 1I0 and 2I0 of the upper and lower multiplexers are selected at the respective outputs, 1Y and 2Y. When the select line combination is B equals 0, A equals 1, 1I1 and 2I1 are chosen at the outputs. For the select line combination B equals 1, A equals 0, 1I2 and 2I2 are selected at the outputs. Lastly, when the select line combination is B equals 1, A equals 1, 1I3 and 2I3. Now let's finish the connections and realize the NOT logic using the 74153 integrated circuit. Since we need only one multiplexer, we will consider the upper mux having inputs 1I0, 1I1, 1I2, 1I3. Connect the 16th pin to the positive 5 volts of DC regulated power supply as illustrated. Now connect the 8th pin to the ground terminal of the same power supply. To enable the multiplexer, connect the first pin to the ground terminal. This pin, denoted as G1, serves as the strobe input for the upper multiplexer, ensuring that the multiplexer is now ready to operate. Connect the pins 3 to low logic, 0 volts, and connect the 6th pin to high logic, that is positive 5 volts. Tie the select lines, that is pin number 2 and pin number 14 together, and record the output from pin number 7. By connecting the tied select lines, labeled as A, to logic 0, we ensure that the input line 1I0 is selected at the output. Additionally, since pin number 6 is connected to logic high, the output at pin number 7 will also be at a high logic level. With the input A now connected to logic 1, the input line 1I3 is selected at the output. Furthermore, since we observe that pin number 3 is connected to logic low, the output at pin number 7 will also be at a logic low level. In today's lecture, we explored the implementation of the NOT logic gate using a 4-to-1 multiplexer, and we elucidated this process using a block diagram. Subsequently, we delved into the internal diagram of the 74153 integrated circuit. We also provided a comprehensive explanation of the functional table for the 74153 IC. Ultimately, we successfully implemented the NOT logic gate using the dual 4-to-1 multiplexer, with the help of 74153 integrated circuit. To our cherished viewers, we extend our warm embrace, for gracing our lecture with your precious time and grace. In the realm of knowledge, we explore and trace a world of wonders, a boundless space. Your presence here, a treasure we hold dear, as we journey through wisdom, drawing near and near. To continue this odyssey, let's make it clear, your subscription and sharing, we humbly revere. With your support, our channel's light will shine, brighter and stronger, like stars that brightly align. So, please subscribe, our dreams we intertwine, together we'll soar, in this knowledge divine.